We love fire. It can be used to run engines, heat soups, give it to a Hawaiian, and it'll entertain us. But can it directly produce electricity? Maybe charge your phone? No, that's not fire. And who would believe that? My team and I are going to use thermoelectric coolers to demonstrate the simple conversion of heat energy to electrical energy. Normally, you apply voltage to the terminals of a thermoelectric cooler, and it would become a heat sink. But, run in reverse, the cooler becomes a generator. Our thermoelectric generators work by a concept called the Seebeck effect. The Seebeck effect says that electrons will flow if two dissimilar metal rods have their ends connected and placed in one hot reservoir and one cold reservoir. Everything is made up of electrons, protons, and neutrons, and electrical current is the loose electrons moving. Let's get one thing straight. Protons don't move, but to understand the Seebeck effect, we need to break that rule a little. To do this, we call protons holes, or the absence of electrons, and we say that the holes move. In our thermoelectric coolers, the two dissimilar metals are called semiconductors. One is N-type and the other is P-type. In the N-type, electrons move from hot to cold, whereas in the P-type, holes move from hot to cold. Holes gather on the cold side of the P-type, so we have a net positive charge there. Because a bunch of electrons gather on the cold side of the N-type, there's a net negative charge there. Just like batteries in series, our thermoelectric generators wind up with a combined voltage between its terminals from all the semiconductors. When you connect those terminals, well, what happens in every chick flick when star-crossed lovers find a path to one another? They somehow don't break their noses when they embrace at high speeds and slobber all over each other's faces. Here's the gist of our generator design. A heatsink on top, a steel plate on the bottom, and the thermoelectric coolers sandwiched in between. We can use that passion to run phones, charge batteries, or, in our case, pump the jams. We assembled the team and made a game plan.
This rate though, it might take a while.
Anthony, get high.
Yeah, let's go! Come on, man! You got this! You got this!
Despite Anthony's cheering, we had a problem. Let us explain.
Yeah, see, look, some of those wires got burlap right here. Wow, that's weird. Like, we should at least got charged, like, at least at the first.
Yeah, it didn't. So, it looks like the tape is melted. It looks like maybe just the tape is melted.
See that one right there? The
Oh,
negative?
yeah,
I see
yeah.
it was grounding out right there, probably.
That was ground putting like each one
So
to each.
we were losing power, at least two of them, and
Instead
then
of, like,
some of
putting them
the
in series like
some
you
of the
did,
negative and
just
positive
put,
were
like,
actually
each
crossing
one
and they
to
melted
each.
onto each other. So maybe
Alright.
we did just go too hot.
Yeah, that's what I'm thinking. Is
Because
that-
if you did on the stove and you were getting 2 volts out of just one, so
know what I mean?
don't make it as hot.
probably
keep
use the
the heat
stove next
source
time,
close
so that's
to
a
it.
little more.
Keep the
we
heat
rigged
source
all
close
this up,
to it
though,
instead
so
of
it's
like.
not gonna look as cool.
I know.
We could use coals. We could try using coals at first.
And
I mean,
just make sure that we've let it burn down. Yeah,
Because I don't think that'll give enough to burn through the wires, but it'll give enough to give us at least
Something.
a couple volts.
at least before it burns out.
Yeah, especially before it burns through the
And
wires.
it'll keep
And
like
do
the
you-
flames from looking
Wait.
over to the top.
Do
Yeah.
you think also we made the pot too cold?
No.
No?
No, the bigger the difference, the bigger the temperature difference, the better, bro.
Had we had some better insulation, more fire would have been better. But since we had too much, the wires weren't insulated very well for like heat, it just melted through the wires and started grounding out to the plate.
Well, I call this a success.
We got something out of it.
We got something
What
out
did
of
we
it.
get to?
Like 200 millivolts.
See, that was close.
Regardless, we moved right along. Josh had an excellent idea. How about we test them individually first, but this time in a more controlled environment. In a matter of seconds, each generator built up around 2 volts. To fulfill the original idea of creating a generator that worked over an open flame, we headed back out to the grill and reassembled the heatsink, hot plate, and thermoelectric generators with one adjustment: a heat shield. This was a little disappointing because we didn't read the 8 volts that we were expecting to get out of 4 2-volt power supplies in series. Also, when placed under load, the voltage across the generator terminals drops drastically. Likely, this is due to the internal resistance of each generator.
There's a light.
I've paid my dues, time after time. I've done my sentence, but committed no crime. And bad mistakes, I've made a few. I've had my share.
There it is.
Let's go.